Welcome to The Explainer. Today, we are diving deep, really deep, into one of India's most ambitious missions. They're on a quest for treasure at the bottom of the ocean, but what they're finding out is, frankly, pretty alarming. So what's down there? We're talking about a place very few people have ever laid eyes on. It's a world of just crushing pressure and absolute total darkness. And this is exactly where one of India's most ambitious scientific missions is headed. Just to give you a sense of how deep that is, you'd have to stack, 13 Empire State Buildings end to end just to reach the bottom. And the pressure down there, it's over 600 times what we feel right now on the surface. It's an environment that's just incredibly hostile to pretty much all life as we know it.
Okay, so this huge undertaking has a name. It's called the Samudrayaan project, and it's a really big piece of India's much larger deep ocean mission.
And the goal here is pretty straightforward. India wants to join a very exclusive club. We're talking about nations like the US, Russia, and China, countries that have the tech to actually send people down to explore the deepest, darkest parts of the ocean.
And how are they going to get there? Well, at the very heart of this whole mission is this incredible piece of technology, a real testament to India's engineering skill. It's called the Matsya 6000. Okay, so this thing is a beast. It's a 28-ton submersible, and it's built around this sphere made of a super thick titanium alloy. That's what's going to protect the three-person crew from that insane pressure we talked about. And get this, the life support system is incredibly robust. In an emergency, it can last for 96 hours. That's 4 whole days.
You know, what's really fascinating about this whole project is how it came to be. Originally, they tried to buy a submersible from other countries, but they were denied the technology. So what did the Indian scientists and engineers do? They just said, fine, we'll build it ourselves. It's this amazing story of national self-reliance.
Right, so they're not just diving straight down. This is all happening in very careful stages. First, some manned trials in shallower water, then unmanned tests in the deep sea. And the grand finale, the full 6,000-meter manned dive, is planned for the same year India is sending its astronauts into space. Talk about a statement, right? Conquering the depths below and the heavens above all at once. So, the big question is, what is this incredible machine actually looking for down there? We're not talking about some mythical kraken or sea monster. No, this is a treasure of a very different kind, and it's way more valuable. For decades, scientists have known they're there. Just vast fields of these mysterious, kind of potato-sized rocks scattered all over the seafloor, just sitting there, waiting in the complete darkness. So what are they? They're called polymetallic nodules. And this is the main target of India's mission. They literally form over millions and millions of years. Tiny bits of metal from the seawater just slowly build up around a little core. It's kind of like a pearl growing in super slow motion, right there on the bottom of the ocean. And why are they so important? Well, it turns out they are packed with metals that are absolutely essential for our modern world. I'm talking about the nickel and cobalt in your smartphone, in EV batteries, the copper in all our electronics, the manganese we need for steel. It's all down there. So how much are we talking about? In the area of the Indian Ocean that's been allocated to India for exploration, the estimate is 380 million tons of these things. Let that sink in. We are talking about a potential multi-trillion, with a T, dollar resource, just sitting there on the seabed for the taking. But, and this is a huge but, as scientists started to simulate what it would actually take to mine these nodules, a much more sobering and honestly scary picture started to emerge. And this is the discovery that has everyone so concerned.
And this really gets to the heart of the problem. According to the research, the very act of scooping up these nodules, well, it means that the special habitat where they're found is, and I'm quoting here, permanently destroyed.
Yeah, this kind of mining, it's not a delicate operation. You've got a collector vehicle basically scraping the top layer right off the seabed. Not only does this completely wipe out the habitat right there, but it kicks up these enormous underwater dust clouds. These plumes can drift for kilometers, eventually settling and just smothering all the marine life from miles around. The change is just stark. You go from a living, breathing ecosystem, a place with unique creatures that have been evolving for thousands, maybe millions of years, to a barren wasteland.
And we're not talking about a recovery that takes a few years or even decades. Scientists think it could take centuries for this ecosystem to come back, if it ever does.
To put a number on it, one field experiment found that the disturbance from just one simulated mining run was 30 times greater than any natural disturbance in that area, like from deep-sea currents. It is an ecological shock of just massive proportions.
So, this brings us to a really profound global dilemma, doesn't it? It pits our growing need for these critical resources against our responsibility to protect what is really the last untouched frontier on our own planet. I mean, look at the two sides here. On one hand, you've got the promise of this incredible new source for the very metals we need to build a greener future. But on the other hand, you've got the peril, the permanent, irreversible destruction of an ancient world that we're only just starting to understand. And the long-term consequences? We honestly have no idea. So as we reach for the stars and as we dive to the very deepest parts of our own world, you have to ask, how do we decide which frontiers are worth conquering and which ones maybe should be left untouched? There's no easy answer here, but how we choose to answer that question is going to define our relationship with this planet for a very, very long time.